Hi, this is Kyle Jensen here at Yale to describe to you for Management 656, the Management of Software Development, this lecture, which is JavaScript and server-side applications. Recall from previous lectures that the client, that is, applications running in your web browser, are built on three different web technologies. Those are HTML, CSS, and JavaScript. So HTML describes generally what content is in the application. For example, this header, this paragraph, these buttons. CSS describes how the app should look. So for example, this font or this color. And JavaScript describes how the application should behave. So for example, do this when the user clicks or do this when they search. That is, JavaScript is responsible for the behavior of the application. And in this class, we'll use JavaScript to build our server-side applications too. We'll be writing JavaScript on both the client and the server, which is a wonderful thing because there's no context switch. We're not writing Ruby on Rails in the server and JavaScript in the client. We're not writing Python in the server and JavaScript in the client. We're writing JavaScript everywhere. So here in this chart, you see that we have client-side JavaScript on the left-hand side that is handling things like user interactions, fetching data, and altering the page, altering a web page. And on the right-hand side, we have server-side JavaScript, which is responding to HTTP requests that are made by the browser, storing data, and performing business logic. So computation, for example, on user-submitted data or data that users have requested. And the server sends back to the browser or the client HTML, CSS, and other stuff too, like JavaScript, images, etc., even data and things of this nature, right? So there's these two domains. There's the client side, which is the client-side application, and JavaScript is running in that environment, handling user behavior, describing how the application behaves for the user. And then there's the server side, which is responding to HTTP requests and sending things to the browser. And on the client side, we'll have JavaScript running in any number of different environments, which are different browsers. So for example, Safari, Firefox, Chrome, Opera, Internet Explorer. And on the server side, we'll be using Node, which is I think it's safe to say the predominant server-side JavaScript environment. So first, a little bit of history lesson. Where does JavaScript come from and what is it exactly? JavaScript originated with Netscape in around 1995, 1996, and it was originally called Mocha and was released in 1996, I believe, as a programming language for the browser to make pages interactive, and was not the first of its kind. There were other languages that existed that provided interactivity in the browser. It happened to be the case, though, that JavaScript, which was originally, after it was called Mocha, was called LiveScript, and then perhaps was released as called JavaScript when Netscape 2 was released, I believe. And the programming language, JavaScript, was copied by Microsoft for Internet Explorer 3 and called JScript. And so because it had, those were the two predominant browsers at the time, because they had standardized upon this single language, it became a standard. It became something that everyone agreed to, and it was called ECMAScript. And ECMAScript now is used in a variety of contexts. And so, for example, on the left-hand side, you see a variety of different browsers. For example, Firefox, Google Chrome, Apple Safari, and their implementation of the ECMAScript standard. So Firefox is at JavaScript 1.8.5, and as you might imagine, Adobe Acrobat is at 1.7. And there's different kinds or flavors of ECMAScript that are implemented by all these different environments here. And there's one in particular that we're going to talk about on the server side, and that is the V8 environment, which was created for Google Chrome. There's a clever fellow named Ryan Dahl who noticed that when he was uploading an image, I believe, to Flickr, that Flickr didn't have any idea how much of the file was left to upload, and thought that that was ridiculous. And it was really due to the nature of programming languages available on servers. So we were writing code in PHP or Java or Python or Ruby, and some of these languages that weren't by their very nature what you would call evented, or didn't have these kinds of properties that would allow people to create wonderful real-time applications. And he knew JavaScript to be a language that would be great on the server side. And recently, Google had introduced Google Chrome and created for Google Chrome the V8 JavaScript runtime, which is embedded within the Chrome browser. And that is their particular implementation of ECMAScript. And so this fellow Ryan Dahl created an environment called Node, which runs on top of V8 on the server, which allows JavaScript to run instead of the browser on the server. And by server, I mean on a computer sitting in a cloud somewhere in a giant rack, not your browser. And Node really took off for a variety of reasons. First, it allows developers to write JavaScript both on the client and on the server. And this is super important, right? If you're a startup company, people are your most important and expensive asset. And why would you like to hire a Rails developer, a Python developer, a Java developer, and a JavaScript developer, right? It's much simpler if you can hire a single kind of developer. As well, for your developers who are capable of writing code in multiple languages, there's less of a context switch. And so I think that's the most important thing driving Node's adoption. I think the second that you could say is that Node has some very interesting properties, including its predisposition or ability to create wonderful real-time applications. That is, things like chat or, as we said, file uploads that have progress indicators and things of this nature. And that is because Node is inherently non-blocking or evented. And you can look up online what that means. But the bottom line is that it handles a large number of requests and it isn't stuck handling one request while it's before it can handle another. And so Node has become very popular in a very short amount of time. You can see here Google Trends comparing Ruby on Rails to Node. And this is not to say that Ruby on Rails is any better or worse than Node, only to show you that over a short period of time, Node has become quite popular. And it can be used and will be used in this course to write a server-side web application that responds to HTTP requests. And that is essentially what a server-side application does. So on the client side, JavaScript is controlling how your browser, how the browser responds to user input, how the browser behaves, okay, how the HTML and CSS is manipulated in a response to the user. And it is also, in the background, placing HTTP requests to a server. And that server listens for HTTP requests, which you recall is Hypertext Transfer Protocol, and parsing those HTTP requests and sending back responses. And those responses may include HTML, they may include CSS, they may include JavaScript or images or whatnot. And many clients are connected to a single server, and this is obviously called the client-server architecture. So, for example, if you look at the SOM, the Management 656 website, there's many students. There's only a single server, and that server is listening to requests from your browser and responding to those. So what happens when you browse to a website? So, for example, here is reddit.com, and when I pulled up Reddit in my browser sends a HTTP request, and this is shown here. So there's a little block of text that forms the core. This is a very minimal HTTP request, and it has a couple different lines. First, it says get, which is a HTTP verb. It says get me this page, and the page is slash. So if I go back and look at this, you can see it's reddit.com, and it has nothing after it. Slash is the naked domain, essentially. There's no path. And the protocol is HTTP 1.1. There's different HTTP protocols. And accept means that it accepts any content type. So it might accept HTML, it might accept JSON, it might accept an image, and so on and so forth. The browser is not specifying what it will accept. And it accepts different kinds of encoding. So it accepts gzip encoding, which is a compressed type of encoding, or deflate, which is another compressed type of encoding. And it's requesting these data from the host www.reddit.com. Okay, and let's take a look at that we'll look at my computer here and see what that looks like in my browser. I'm going to open up my Chrome JavaScript console and go to this network tab here. Make this a little bit bigger and refresh this page. And what we'll see is a variety of requests that my browser generated. And this first one here is a GET request to reddit.com. And you can see here are the request headers. And this is roughly what I showed you in the previous slide, except that there's a little bit more detail here than I showed you. So the request was to get reddit.com. The request method was get. It accepts these kinds of content from the server, these kinds of encoding. So there's 3 different encodings that it accepts. It accepts this language, it accepts English. It prefers English, that's what that Q means. And there's other kinds of things that tell the server how to respond to this request from my browser. And you can see there's many other requests. So when the browser received this response, and here's some response headers, and then there's the response body. And the response body is a bunch of HTML and JavaScript and so on and so forth. And some of these things in here, for example, you see there's links and there's CSS that's included in images. And then the browser proceeds to download those things. So it's downloading Reddit's CSS here. And Reddit has the CSS that is compressed. It's all the spaces have been removed and it's shoved together in one big long string. And then it receives, requests all the images that are on the page. So for example, here we're requesting an image, which is one of these thumbnails on the left-hand side here. And you can see all of the requests that were initiated just by me visiting reddit.com on the left-hand side here. And for each one of these requests, there are headers that were sent to the web server. And then the web server responds with an HTTP response that includes headers and some content. And I can preview all those in my Chrome developer tools. You can preview them using the Safari developer tools, Internet Explorer. There's developer tools available in most modern browsers. So all browsers make HTTP requests. That's what they do. When you visit the New York Times, it makes a request. When you visit Reddit, it makes a request. When you visit Yale, it makes a request. Facebook, doesn't matter what it is. Hair plugs for bald men, which I visit frequently, makes a request. When the server receives this request, it responds with a response, right? So here's the request. When Reddit responds to that request, it sends the following. As I showed you in the Chrome developer tools, there are certain headers that it sends along. So for example, this is HTTP 1.1 protocol and the response status code is 200. 200 means okay, everything went just fine. There's other status codes like 400, which means that was an invalid request, or 500, which means that there was an error on the server, or 404, which means I couldn't find what you were looking for. And then there's all sorts of other headers. So for example, content encoding gzip, which means the response is compressed. The content type is HTML. The character set is UTF-8, which means we can send along Chinese language characters and it will display just fine in the browser. And it includes the date and all sorts of other things that may be interesting for the browser as it renders the response for the user. And then at the bottom is the response content. And here I've truncated this, but in the case of Reddit, it's a large HTML document. So how do we write a server that responds to HTTP requests? We've established that the role of a server is to listen for HTTP requests and to respond to those. But how do we go about writing one? And that is the topic we will address now. It's easy, and you can do it in a number of languages. So you can write a server in Go, you can write it in Java, Objective-C, Python, Scala, Ruby, C, Perl, whatever. We are going to write in JavaScript, and we're going to use Node to write our server applications. So let's write hello world for Node.js, and let's do that in a separate lecture.